Welcome and thank you for joining us for this webinar presentation. We are the Homeland Defense and Security Information Analysis Center, or HDIAC, one of 3 IAC domains in the DoD Information Analysis Centers operating under the Defense Technical Information Center, DTIC, within the Office of the Undersecretary of Defense for Research and Engineering. Our informative webinar series highlights current and emerging research and technology developments. It presents an opportunity for accelerating the DoD's leverage of these advancements by increasing awareness and fostering technical collaboration. HDIAC serves as one of the premier information research partners and curators of technology advancements and trends for the Homeland Defense and Security community. As such, our organization supports those working in the Homeland Defense and Security domain of DoD research and engineering. We do so by helping navigate the vast landscape of scientific and technical information, allowing our customers to get a head start on their technical projects. With an understanding of the Homeland Defense and Security DoD research and engineering landscape, we provide research and analysis services. We help unlock access to information, knowledge, and best practices from government, industry, and academia to stimulate innovation, foster collaboration, and eliminate redundancy. We hope you enjoy this webinar presentation and that it serves as a catalyst for community collaboration and improved DoD Homeland Defense and Security research.
Good day, everyone. Thank you for joining this webinar presentation. My name is Philip Payne. I am filling in for John Clements, the technical lead of the Homeland Defense and Security Information Analysis Center, or HDIAC. Before we get started today, I would like to note a couple of administrative items. First, if you are dialed in by phone and would like a copy of the slides, they were posted to the CSIAC webinar announcement. You could go to csiac.org/HDIAC.org/webinars, and find today's webinar. When you click on it at the bottom of the announcement, it will say to view webinar slides, click here. Second, all participants are muted, but feel free to chat using the attendee chat window on the lower right-hand side of the screen. You can chat with each other and I'll be monitoring that chat as well. However, if you'd like to pose a question for the Q&A session at the end, please click the icon with the 3 dots icon labeled More Panel Options to bring up the Q&A window as part of your layout. At the end of the presentation, I will go over the Q&A. For the benefit of those on the phone, I'll read the question out loud to the presenter. If you have a technical issue during the presentation, have no fear. The full presentation will be available online. Please check back to the HDIAC website once the webinar is posted. The Go To Webinar button will take you to the YouTube link. And with that said, I'll introduce today's presenter. Dr. Stowe is the director of the Oak Ridge Enhanced Technology and Training Center. His prior roles included CNS University Partnerships and Minority Serving Institution Partnership Program Manager. He was named a Y12 Guggen Fellow and Director of the Nuclear Forensics and Detection Initiative. In that role, he acted as a technical lead, coordinating technology transfer and partnerships for radiation detection technologies. Upon completion of his term as fellow, Ashley became the Fellows Program Manager. He joined the Y12 National Security Complex in 2007 as a Senior Development Chemist. Dr. Stowe was recognized with a 2013 R&D 100 Award for his pioneering development of the lithium-based semiconductor radiation detection crystal in collaboration with Professor Arnold Berger of Fisk University. That said, we'll get started with today's webinar. Thank you.
All right, thank you, sir, and thank you to HDIAC for the opportunity to share the great things going on at the Oak Ridge Enhanced Technology and Training Center here in Oak Ridge, Tennessee. We are part of the Y12 National Security Complex, which has a mission to provide the nuclear deterrent for the NNSA within the Department of Energy. And our role is to provide advanced training in high consequence scenarios by leveraging the 80 years of experience at Y12 in radiological response in nuclear material handling and things of that sort. So ultimately today we want to talk to you about our new training campus. We opened our training campus on January 9th of this year, and ORETTC, as we call it, is not only a facility or a campus, but it's also a capability. The building that we sit in is 43,000 square feet. It's a classroom facility that also has a lot of unique immersive training technologies built into it. And our staff is a combination of subject matter experts in radiation response, in nuclear material accountancy and control, in physical security, and other disciplines. But we also have subject matter experts in adult learning, as well as having subject matter experts in video production, augmented reality, virtual reality, et cetera. So we bring this whole team together to design the best training for our customer sets across a global security portfolio. And then we execute that training. Some of that training happens on campus with us. Some of that happens virtually using our video production studio, as I'm presenting with you today. And then we also go out into the field and present on location across the country and even across the world. As we do that, we have a research team that is looking to innovate in the learning technology space, using and developing immersive technologies. And as we look at these technologies are only good if they're providing, if they're working as a learning tool. So everything that we do is through an educational lens. So here is a photo of our building as we opened. As I said, it's a 40,000 square foot facility, 43,000 actually. There are close to 50 hard-walled offices. Right now we have that populated with our CNS Y12 team. There are 13 training rooms, collaboration rooms, and 8,000 square bay that is a multi-use facility or multi-use space for larger scale training exercises and classes. This building is just the first building on our campus. We already have funding for a second building. We call that SINRAF, or the Simulated Nuclear and Radiological Activities Facility. And if this campus is being built through a state and federal partnership, so the building that I'm sitting in today that you just saw a picture of is the Emergency Response Training Facility. That's actually a state-owned building that we are operating out of. And our second building will be a federally owned building as we continue that partnership. The state facility is more of your classroom space. It's a low hazard space where we leverage simulations. And the second facility will be more of the industrial laboratory space. We'll have mock processes where you can take what you learn in the classroom, what you've practiced on in simulations, and put that into realistic exercises at a larger scale. Beyond these two buildings, we already have plans in place for other additional spaces to round out our training capabilities, anything from shoot houses to cyber test ranges to rubble pits and fire towers to engage our trainees appropriately. So one of our core courses is an emergency response training course. We do this through the Office of Radiological Security in A21, and we bring in first responders from around the country, local police, on-site security at soft targets that would have radiological and nuclear material. So think of hospitals, blood banks, research centers, test reactors on university campuses, things of that nature, where there are nuclear materials or radiological sources in lower production environments that potentially are easier to access by an adversary. In those cases, we, through this program, are teaching the buildings, the locations, the facilities, how to think about protecting their materials, but also working with the response forces, the local police departments that will be the first to arrive on the scene, and making sure that, one, they have the monitoring in place to protect the material, but two, that they respond in a coordinated fashion. And we don't teach the tactics specifically. We just give those groups familiarization training so that they can test their tactics in realistic environments, and so that these multidisciplinary teams have met and communicated about what their tactics are and deconflicted any mismatches in their tactics before it's game time, before you have a real event. We do that again by starting in the classroom. We use as little PowerPoint as possible, but sometimes it is necessary to be able to deliver some of those fundamentals. We then quickly move beyond that to more hands-on types of interactive training exercises and scenarios. We use a variety of technologies in order to provide that realism and that immersion. Some cases we will use a large LED wall in the bottom left image, make it look as though it's a fire, bring the fire truck into our high bay and use that as a training tool. In other cases, we use augmented reality and do tabletop exercises where we not only walk through the scenario where you can play out your tactics, but using game engines that are similarly used in Call of Duty and other types of high-end video games. We can run the simulation to test out whether or not their tactics were effective, and then discuss what worked, what didn't work, and then reset those types of scenarios. We can also walk through, sort of in a first-person style, what something would look like in a high-hazard scenario, let them see the situation and respond to that situation. And then ultimately we turn our building or our campus into the prop itself. And at the end of a training week, we will bring in role players to play the adversary and walk through training exercises to take what they've learned in the classroom, what they've practiced in these tabletop exercises, and play those out in a real life exercise. And then again, it's all about debriefing what worked, what didn't work, where were your communication breakdowns, your tactical breakdowns, and how can you respond differently to improve your response. From this, we would then have follow-up refresher style trainings that would add on over time to keep the local law enforcement, the groups that we work with, at the top of their performance. So again, as we think about our training, sort of our philosophy is this tiered approach. Again, you start in the classroom, move through simulations into field training, but it's not just within one course, crawl, walk, run, but it's also about thinking through how do we integrate those all the way up the decision tree to integrated teams and how they're making decisions. And so we build that into all of our training protocols. And I want to spend a little bit of time talking about the rest of about how we think about our simulations. There's a lot of really interesting technologies out there, a lot of, some people would call, really cool toys. Ultimately, we don't use toys. We have technologies that we turn into training tools. And as we think about building our trainings, we have training tools, different technologies that we introduce as part of our courses in order to enhance the learning transfer, the knowledge transfer to the learner. We do that by providing more realism and more immersion in the scenarios, especially in these high hazard scenarios where if you talk about it sitting around a table, you don't have that stressful response that you will get if you see a fire breakout in front of you in a simulation. And so we try to bring those technologies into play. and think about what's a unified strategy in what's called XR, or extended reality. And so with these technologies, there's actually a spectrum across the mixed reality space, everything from the real environment where you walk up to a physical piece of equipment, you're running around a physical building with role players playing the adversaries on one end, and then on the other end, you have a fully digital universe. So think Ready Player One, the recent movie where you put on a VR, a virtual reality headset, and you enter into a completely different universe, separated from the physical space that you're in. Then across that, you have augmented reality and augmented virtuality, where you can have some physical objects and overlay a digital input. You can have a real piece of equipment, but then overlay an emergency response scenario so that you can practice on it. In augmented virtuality, you're creating an artificial environment, but there's a foreground that you can interact with physically. And so you can work all the way across the spectrum. And as we build our training, we think about what's the right tool at the right time to achieve the learning objective. So beyond the high consequence response, we are thinking about a variety of training categories, use cases. For us, we have on-the-job type training. This is the stuff that you would have in a manufacturing environment where you're teaching processes, you have work aids, and again, they're training tools that where we think about what is it you're trying to learn, how can that be used either offline in a training bay or online out in the actual work area to help you do the real job. Also weapons training where you're doing assembly and disassembly kinds of activities, scenario-driven exercises where it's really about tactical decision-making, rad nuke assault type courses where you go into special facilities. And then you have, again, the emergency response, high consequence response, abnormal conditions kinds of scenarios. For each of these, there's a training system that goes into play, and it's everything from the hardware through the software, adding in the educational components. And for some environments, you want to be able to include security requirements to your training set as well. And so within our facility, we're looking at all of these components and thinking about what are the right tools at the right time. We're formally agnostic to all of these types of components, but we do have preferences in terms of what type of technology we use at a certain time. In virtual reality, if you don't have anything there that you can interact with, virtual reality works quite well. Otherwise, we typically prefer augmented reality, where you can interact with others by being able to hand objects between one another, being able to interact with physical objects. In some cases, we actually use what are called haptic devices, which allow you to touch and feel the digital object. Again, in the software regime, there's a number of game engines that we can interact with. But if you're just bringing the hardware and the gaming pieces together without thinking about the education, then you end up with a video game as opposed to an educational simulation. Now, when we think about the use case of secure environments, we have a number of ways that we can interact. Oftentimes, these tools, whether it's 5G connections, Bluetooth connections, Wi-Fi connections, or hardlining them in, they are designed for open commercial applications. And when you need to segregate data streams or have additional protections on the types of simulations, that creates a number of challenges. And so we actually have some research ongoing to look at different ways that we can interact with the within these secure environment regimes, such that we can still do the training the way that we need to, and protect the information appropriately, or authorize access and at the appropriate levels in order to do that. I won't go into much more than that, only to say, if we think about a typical headset, this happens to be a HoloLens, you are bringing in a variety of technologies that most places already know what to think about. Excuse me. There's IR emitters, there's cameras, there's data storage, there's some sort of communication, wireless communication. All of these things, there are protocols to deal with in a secure environment, but they're being put together with a different form factor in a headset. And so we're doing different types of experiments and studies to be able to show how we can use them, how we can protect the information properly, but ultimately thinking about the risk matrix. Now, when we think about this, how immersive can we be? We have a high bay facility. Again, it's about 8,000 square feet. And the LED wall that you see there is 9 feet tall by 45 feet wide. And we can turn that into a green screen and do green screen production. We have on our team experts at doing video production that allow us to create training videos that not only show a trainee a scenario of an adversary moving through their hallways, or someone trying to take their material, or any other type of training scenario, but we can do that and overlay those activities within the trainees' facility themselves. Oftentimes we'll ask them if they can walk through their hallways with a phone and take a quick video. We'll then overlay that, and when we're sitting in a training talking about how would you respond, and it's a generic facility, you can get some level of engagement. But when they see the facility that they work at in the background, and someone walking through their facility, they respond in a very different way. And so again, this is how we think about engaging the learner to enhance that knowledge transfer. We've already received funding to upgrade this setup from a wall that you see in this image to a full LED volume. It'll end up being 35 feet wide, 16 feet deep, and again, 9 feet tall, so that a trainee that walks into that space will see only the environment that we create. The LED wall or the volume runs on a gaming engine, and so we can integrate the synthetic environment fully into what the trainee experiences, and then we can tie in a variety of augmented reality tools, motion tracking. We can track multiple individuals as they move and interact through the space in a simulation. We can have physical objects, digital objects. By bringing in haptics, we can also bring in the ability to touch, feel, pick up, feel the weight of an object. If it's a manufacturing simulation, we can create a manufacturing process floor and some pieces of equipment. An individual, a trainee, can walk up to that piece of equipment. Work instructions can pop up to tell them how to do a certain operation, and if they need to turn valves or pick up an object and move it from one place to the other before or after an operation, they can go and physically, they can pick up the digital object, and it feels as though they're physically picking it up because you feel the weight of it, you feel the texture of it. When you go to turn a valve, if you're using a joystick or a sort of a mouse kind of operation, it's always a perfect turn, a perfect click. If you are using these haptic gloves, it is much more of you have to know how to turn it. If it's a torque, you need to feel the nuance of using that torque wrench to get it to turn properly as opposed to over tightening it, etc. And so this is where we can take the physical learning that you would get from a typical mock setup at a physical piece of equipment, and the mental learning that you would get from working through a web-based scenario or a virtual reality, augmented reality scenario where you have a joystick clicking through things, and we can combine to get the muscle memory in a digital environment. I'd like to give one other example, and I don't have a slide of this, but in that manufacturing setting, we've actually designed a glove box scenario to teach people how to feel comfortable, how to get used to working in a glove box. And we chose this because it was a generic example of a manufacturing environment that was highly transferable. We're doing some educational research to understand, does a virtual environment work as well to train someone on using a glove box as using a real space? And we're doing this by having people learn on a physical glove box, learn on a digital glove box using virtual reality, and then learn on a digital glove box using haptic gloves, where you can touch and feel. And I can tell you from my own interactions with the prototype, when you go into the gloves, you feel the pressure of pressing into the gloves because it's a positive pressure glove box. And one of the more surprising things to me was, after working in the simulation for about 10 minutes, my shoulders began to get sore because I'm working at a distance, because in the simulation, there's a perception that there's a glass in front of you and you can't move through it. And when you go to touch the glass, you actually feel the resistance of that glass itself. And so even though there's nothing physically in front of you, the perception within the simulation is that you're working in a glove box, you have limited mobility. And so you can see people contorting to reach for something without moving through the glass, working at a distance. And those are the types of things that we are trying to train along with the technical skills. It's testing, how do they handle the fatigue? Can we get them used to the fatigue of working in a glove box? And ultimately, once we train them and get them into a fatigue state, then we can apply in abnormal conditions to see how they respond in fatigued, stressed situations. Because the reality is, that's usually when it happens in real life, is when you're fatigued, when it's at the end of a shift or the end of a day, and you still have to make the right decisions, even though you're fatigued, even though you don't deal with this condition every day. All right, so I will end with this. We can't do all of this by ourselves. We have a strong set of partners that we do this kind of with. The University of Central Florida, Roane State Community College here locally in Oak Ridge, Avrio, a small business located in Knoxville, Tennessee, IB3 Global, which is here locally in Oak Ridge, as well as the Oak Ridge Associated University that helps with a steering committee to guide our efforts. So we focused a good bit on the learning technologies through this briefing, and we are thinking about how we can apply those across a variety of training programs, a variety of training scenarios, everything from a digital twin to help design a new facility, through processes, manufacturing processes or repetitive processes, so that you learn how to do certain tasks, all the way to the other end where it's emergency response and decision making in abnormal conditions. And these tool sets can be transferred across those training scenarios as we can, we can use them to enhance those types of training. So with that, I will end my presentation and leave us some extra time for questions.
Thank you very much for that interesting presentation. I have a couple questions myself, but we do have a couple in the chat, so I'll start there. The first question I believe was answered verbally, but the first question was from Merrick. He says, do you use any haptics for the simulation enhancements? I believe you touched on that a couple of times. So I will go to his follow-up question, also from Merrick, who says, for example, how would you approach a nuclear contaminated location decommissioning training? Would it be a virtual presence situation with remote manipulators or vehicle training with infrastructure design understanding? Would it be possible to integrate a contested environment space to ensure personal safety awareness?
So I think the answer is really all of the above at various points. So if you have a highly contaminated space, you can either take known engineering models and create a digital twin of that to familiarize yourself with the space, or you can collect real-time or at least current state scans using LiDAR technology, even LiDAR technology with that maps to gamma imaging technology, such that you can get a real-time view of the state that you have to clean up. And you would use different tools depending on the size of the space. If you've got a building, perhaps you would use a robot to move through the space, collecting LiDAR scans, etc. Some photogrammetry to take the point clouds and overlay the texture of the real objects. From that, you can build a digital twin that you could walk through to understand where your problems are, where your hazards are, from a familiarization and a planning standpoint. You could then go back in with a telerobot of some sort that would act as a manipulator. We're using the Haptic brand gloves for our work. There are other haptic glove companies out there, but I'll speak to what we know. The Haptic brand has a telerobot where the robot itself has air bubbles on its surface of the robotic hands that map over to what you feel. And so you have a wide angle camera at the head position between the robotic arms on this telerobot that you can see real time through virtual reality headset. And so you can interact remotely, separated from the hazard, with the whatever's in front of you. With that, you still have the level of dexterity that you can pick up objects without breaking them. The example that I was able to experience was picking up one solo cup off of a stack without crushing it or without picking up the whole stack. And so it gives you a high level of dexterity and the sensitivity so that you can pick up objects without breaking them if you have a vial of material or something along those lines. So I think you would start out by building a digital twin of the current state to plan out your maneuvers, plan out where your hazards are to minimize the amount of time interacting with the hazard. And then you can move towards telerobotic applications that couple with an AR or a VR camera so that you can move through the space and pick the things up, do the types of decontamination or cleanup activities, but still keeping your worker, there's a human at the wheel, they're separated from the hazard.
Thank you. Our next question in the chat comes from Alexis. I think you kind of addressed this a little bit, but I'll give you the chance to elaborate. He says, what haptic device are you guys using?
Yeah, so right now we're using a pair of gloves. They are Haptic brand gloves that have, I believe it's over 1,000 micro air bubbles in the palm. And runs off of a compressor that provides air to those bubbles preferentially, so that you feel you're able to get a response on your hand to what you're picking up or interacting with. It similarly has a series of wires that are under tension so that you feel the weight of an object. There's another company called Manus that has gloves, and then we're beginning to see, but we are not currently using other devices that are more like bodysuits or full arm systems that allow you to have greater levels of tension on the body or shocks, physical responses across the bulk of the torso and things of that nature. Right now, we're only using the gloves themselves for our work.
Thank you. The next question comes from Ron. He says, are there opportunities for internships from local or regional universities, especially in gaming, computer science, data analytics, etc.?
So the answer is absolutely yes. I will say that for this summer, our internship starts on Monday. And so we've already selected our interns for this summer. We usually post the internship for the following summer in the September timeframe. So be on the lookout in September or October for opportunities for next summer. But if there's folks online that are interested, feel free to reach out directly to me, and we can have conversations about a variety of other opportunities to collaborate and even work together out of that summer internship cycle.
Next question from David. Can you simulate radiations from alpha, beta, photon, and neutron emitters?
So the answer broadly is yes. In fact, ORNL recently announced a license for a technology called Viper that does just that using an MCMP simulation in their technology. It's a high fidelity simulation, but of a very specific room. There are ways to simulate, and even in our tabletop exercises that we've developed, we simulate a simple radiation response of a gamma source, and then visualize a dose ring associated with a certain strength in isotope. The intent of our use case at this point has been just familiarization that there is a radioactive material that emits radiation, and that as a responder, you need to think about that and think about standoff from that to limit dose to those responding in a certain scenario. There are ways that we are aware of, although we haven't put them into practice yet, to add a variety of sources, integrate detectors so that you can simulate that, and even simulate how you would clean that up, how you would do swipe measurements or detection type measurements. We don't have a current customer that has asked for that, but we do know how to do that broadly.
Thank you. I don't see any other questions in the chat as of right now, but feel free to put those in. We still have some time left within the webinar. I'll go ahead and ask a question that I had while listening to the presentation. So my background is in cyber as a tech lead for the Cybersecurity Information Analysis Center. So what I normally see from the AR, VR modeling and simulation training space is normally that the more realistic the simulations, the better as far as training is concerned. But one thing that interests me during your presentation was you made the point to say that some of the training that you guys specifically do are stressful situations, right? When you talk about the nuclear space or working with the fire department, things like that. When you take that into context, do you see that sometimes maybe if the simulation is too authentic or too real, that you see actually that the students become maybe somewhat overwhelmed? You have to kind of take a step back to kind of increase learning to get them to the right state, or do you always prefer that the simulations be as realistic as possible?
Yeah, so that's actually a really great question. We have not seen a student um, uh, pushed to such a state that there are negative health effects, but we are very cognizant of how realistic we're making things. We are able to monitor the biometrics through the headset themselves to understand how the person is responding. But what we tell our participants is, hey, you have the ability to step out of this at any point. It is a simulation, and so anytime that you need to disengage, you're able to do that. We are also looking at evaluating the training scenarios ourselves from a learning standpoint, and so we're using biometrics from that side as well. But so for us, I think we haven't seen individuals be so stressed from the scenario itself. We have seen, and this is a pretty common problem in virtual reality. Sometimes certain people will have vertigo and will have struggles with using the virtual reality because you just lose perception of the real world around you, and it kind of makes them feel uncomfortable. And that's why we oftentimes prefer augmented reality. So we do make choices in terms of whether it's virtual reality or augmented reality based on that physiological response for some individuals. But to answer your question specifically, no, we have not seen that yet, but it is something that we're actively watching for and monitoring to make sure that we're making our trainees the appropriate level of uncomfortable, I guess is the right way to say it. We don't want to stress them out too much to where they're from a training standpoint, it's not helpful.
Thank you. That was a great answer. Our next question from Ron: are there opportunities for emergency public information risk crisis communication available through your programs?
I would say the answer is probably yes. Much of our training is what we call public release information. So we're training municipalities, local fire departments, police departments from around the country and even around the world. So the information, the training materials that we have, we try to make as open and accessible as possible. There are certain lanes that we do have to stay in, but we are outside of Y12's physical and IT barriers on purpose so that we can be more open to help be an asset to the community at large in the emergency response kinds of training spaces.
Next question from Adam: what was the difference between augmented and virtual reality? Are any of these an example of the metaverse concept?
Well, so the definition of metaverse is a bit ambiguous in and of itself. It's really a continuum. So, dealing with everything that's physical, nothing electronic, that is at one extreme of the spectrum, and then everything completely virtual, you lose perception of the world around you, is at the other end. Augmented reality, simply put, is you have a digital overlay to augment or enhance the physical world around you. This is kind of the Tony Stark Iron Man approach where he's interacting with the real world in the Marvel movies, but he has a heads-up display in his mask that show things, or he has a workbench where he has sort of holograms of digital objects that he can interact with and manipulate. In augmented virtuality, it's really, again, just a little bit farther to the extreme where you're extending your field of view into a virtual screen. So it's a physical screen that's giving you a greater depth of field by projecting the digital universe beyond the physical space that you have. And then again, you can get all the way to the virtual space, which is kind of that Ready Player One type of scenario where you've got someone sitting in a physical space, but no perception of it. Everything that you have that you're interacting with is a digital object.
Thank you. That's a question we get on our side a lot as well. You know, my cyber background, but I'm really a sports guy, so I kind of explain augmented reality in layman's terms, and I say, you know, that yellow first down line in football or that strike zone in baseball. Those are things that are not there, but they're overlaid the real world, so you can kind of see it. So I don't see any other questions in the chat. One other question that I did have, because there was a good conversation about haptics. Personally, go to these exhibits or you come across these haptic companies, you see a lot of the cool stuff that they do with gloves and the pressure monitoring and things like that. One of the questions that I did have, I'm not sure if you come across this with some of the haptics products that you may have used. Is there work being done to kind of implement, in addition to just the sense of touch, a degree of like temperature? I know you say you're doing works with the fire department, so if you touch something and see that it's hot or cold, I know that's a slippery slope and that could get very dangerous pretty quickly, but I'm not sure if you've seen anything related to including temperature to some of these haptic devices. Over.
So there's not a whole lot I can say on that topic other than I'm aware that people are discussing including additional functionality beyond force feedback and cutaneous feedback. So forgive me for evading the question, but yes, I'm aware that people are looking into other types of feedback and interaction of digital stimuli within the haptic. I'll say the haptic gloves, but it's really the haptic accessories. And at this point, it's really the gloves are the closest to market, but you really have full body suits that are being developed and all the bits and pieces around that.
Thank you. Next question from Ron. Do you conduct facility tours?
Yes. We typically try to limit our tours to Tuesday mornings, but again, if you or your team would like to have a facility tour to understand our capabilities at a greater level and potentially talk about collaborative opportunities, feel free to reach out to me. I think we can put my email in the chat, and we're more than happy to facilitate those opportunities. And also one other question that I think came. I see Mark put it to everyone about different headsets. We use Magic Leap as well as HoloLens in the AR space. There's advantages and disadvantages to every piece of hardware. But we do use Magic Leap quite a bit. In the VR space, we have HTC Vives. We've looked into Volio, Oculus, a variety of different, pretty much all the different headsets that you could imagine. We try to be agnostic, but there are some that offer advantages in terms of usability or capability.
Thank you. With that being said, I don't think there's any other questions in the chat. There was a great presentation, great Q&A, a lot of interaction from our membership. We strive to accomplish with these webinars. These are one of our only live products and services that we do offer. But with that said, I'll conclude today's webinar. I would like to thank our presenter. Also like to thank John. I know he was busy today, letting me sit in. I learned a lot today personally. But within a couple days, please check back to the HDI website. We will have this recording uploaded to the HDI website as well as our YouTube page. If you have any further questions for us, please feel free to reach out to the contact alias. A bunch of us get that here. We'll be able to attack that, and also so that Dr. Stowe put his information within the chat, so you can reach out directly to him. And with that said, we're logging off. Hopefully, we will see you back online next month. Thank you.
Thank you.